Hi everybody, I just wanted to quickly introduce my most recent project, which is the first project I did for the Sparks Foundation internship that I'm doing right now. It's this one here, which is a supervised machine learning project. It's more of a linear regression project. I use Python, and the aim of the game really was to take a lot of test scores and how many hours each student has studied for, and predict what their score would be if they studied for 9.25 hours. So this is my my project. So what we're going to do is we're going to start off here on the section 1, which is the data exploration and preparation, right? So to start our analysis, we begin by loading the data and exploring its structure. The dataset consists here of 2 columns, which is hours and scores, where each row represents a student's study hours and their corresponding score. So let's take a look at the code snippet here. Just to quickly kind of load, and we used head then to just check the first few rows. Then it was on to data visualization. Now that we have all the data loaded, it's time to gain some insights into the relationship. So we looked between the study hours and the scores. I visualized the data using a scatter plot to observe any potential linear trend. And you can see the snippet there. You can see a pretty strong positive linear regression there. We split the data then. So what we did was we split them up into study hours and output or scores variables. This step allowed us to train our model on a portion of the data and evaluate its performance on unseen data. So again, just having a look at the code. And of course, the fun stuff next, model training and evaluation. With our data split now, we can train a linear regression model and evaluate its performance. So we'll use the linear regression model from the scikit-learn, which is a package in Python for this purpose. After fitting the model to the training data, we make predictions on the test data and evaluate the model's performance using the mean squared error, MSE, or R squared R2, and R2. So let's have a look at that. And there's our scores here. That's all explained within the project itself if you want to have a look at it. So then onto the fun stuff, which was actually predicting the score. For the student who studies 9.25 hours a day, so we used our trained model to compute the probable score based on the given study hours. We got to like 93%, 93 will be the score, predicted score within that. So in conclusion, the analysis reveals a strong positive correlation between the number of study hours and the scores achieved by students based on my linear regression at least model. If a student studied for 9.25 hours per day, we predict their score will be approximately 92.39. Yeah, that's obviously comes with a lot of caveats, etc. There's a lot of other factors that have to do with the student's ability to score. So the model's evaluation metrics included the mean squared error and R squared score. It indicated it's a good performance. These results suggest that our model accurately captures the patterns and trends in the data, explaining approximately 97% of the variability in the scores. Yeah, and that's really it. A little green bar here indicates where that 9.25 hours is in our linear regression. I hope you enjoyed this. Hope you got some value from it. Yeah, thank you.